very relaxing speaker about failure.
I hope that no one will fall asleep after the session. If someone lets me know, I will speed up because I know that I'm speaking. So let's go. About me. My name is Robert. I'm experienced in Cassandra production for the last 8 years in different companies, 20 satisfied companies I'm working for. I'm working in 4 different. I jumping where is some issue. Normally during the day I'm the consultant in Team AB, it's Czupioł. It's a Swedish company, but now acquired by Visa. So I'm working for Visa. I'm the producer of plastic cards, basically. I'm also consultant of CWB, but nothing to talk about that. And I also the DevOps guy, FinOps, SRE on AWS and GCP. So I love to jump into the DevOps stuff from time to time. So, do you know what is that?
Yeah. Point.
Sorry? Any ideas?
A black hole.
Yeah, it could be the circle, it could be something. It's the view from above. It's very popular when we are creating some diagrams about Cassandra. We are creating the view from above. This is one Cassandra node, and basically it's the most popular Cassandra cluster because every people who are using some initial container test, starting with some single node cluster, and they test inside the Java code some Cassandra behavior, if it's working, not working. So it's very popular. But let's jump next. We have that multi-node cluster. A lot of nodes, 3 different tracks, 1 region on AWS, 3 different availability zones. That is more important. Next time I don't let my daughter to private to draw that. Sorry for the quality of image. And normally we have the multi-DC cluster. So a lot of nodes in different availability zones, blah, 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 blah. A lot of that is a normal Cassandra configuration in a lot of companies. And why it's so important? Because of that. We have a lot of arrows. We know what is that. It's the communication between the nodes. So when the node Cassandra is running, it's like the distributed microservice. It's started a lot of connections. There's an inbound connection, outbound connection, and it's a lot of that arrows. We mainly focusing on the internals, what's going on inside that node, but we from time to time forget what is going on that arrows, on the communication. We know that the throughput between the nodes is not so important. When we are choosing, for example, on AWS machine, we are choosing the number of cores, number of CPUs, the number of CPUs, the memory, but we are not choosing, for example, the bandwidth of network, because no one cares. The network is something that exists and it's working every time. So, like that, but it's working. Normally, it's working, a lot of arrows, it's working, it's great. So, let's back to primary school, the speed of light. So, it's 300,000 kilometers per second. I'm not aware with the miles. I'm aware with the kilometers. So it's the 200,000 kilometers per second in fiber cable because there is the interference inside that. So it's 200 kilometers per millisecond. If we are thinking about database, which, for example, which we are querying, it has the response in, for example, 1 millisecond, 2 milliseconds, 5 milliseconds. We want to have average, for example, on 10 milliseconds. But there is a physics. So we cannot, for example, be faster than the physics, than the speed of light. So when we, for example, have the database, which have 2 regions, for example, here in the Denver and in San Francisco, the distance is exactly 2,000 kilometers. The latency is what?
10 milliseconds.
Yeah, but it's also down. Of course. So it's 20 milliseconds when we want to send some information in the best scenarios, because between that is a lot of hardware and a lot of different stuff. So it's 20 milliseconds of pure connecting just by fiber. I will back to that later. So since Cassandra 4.0, we have the internal communication based on Netty. is the non-blocking WebSocket connection. It was rewritten in Cassandra 8, 4, 5, 6, and after that it was also optimized in 1.4, 8, and 5. But I decided to now go to these internals because previously session was a lot about internals. I will be talking about the externals, about the behavior of Cassandra. So inside that, Cassandra creates, inside Cassandra, after introducing the Netty, there are 4 different channels. The first one is the urgent information. Inside the urgent there is a gossip message sending, the small information large, and the streaming and legacy. Legacy only for inbound when we are doing the updates of Cassandra, for example, from 3.11 to 4.4. Important. There is also framing, which was also added into that. We have different kind of framing. The first one is anti-text, so there is nothing. But normally we are treating between LZ4 and CRC just a control zoom. And it's set up in Cassandra YAML in this internode compression. So when we have enabled internode compression, like here in DC, the traffic between data centers will be compressed by LZ4. The traffic inside the data center will be not compressed. We want that, basically. If we are set up intercompression to none, everything will be by CRC, will be just calculating the sum. Okay, and the second parameter, which is also very important, is the no delay. So it was not added to Cassandra 4.0, it exists previously in 3.11. I think that even in 2.1, there is a no delay. This is the parameter. When we are, for example, when we want to send some information from node to node, we are getting that information into one frame. We are waiting in that frame for some time, or when the frame will be, for example, containing a lot of kilobytes, and then we are sending that to another node. And basically, the default of that is the inter-DC no delay. It's false. So when we are sending the information between the data centers, we are using that delay. So we are waiting to get all this package into one frame and send that. It was important to say that. And no delay working on Nagel's algorithm. It was invited in 1983, if I could remember. You can read that, but basically, when we require a low latency connection, we have to bypass that by set up this TCP no delay as a true. So we don't want to delay our communication. We want to send package immediately. So I go on the production previously on lower environments from 3.11 to 4.0. It's very common thing. I'm using AMI rollout. So basically, when I'm working on AWS cloud, I'm preparing by Packer new AMI, which contain the desired version of Cassandra. Inside is the desired version of Ubuntu, configuration, and blah, blah, blah. And then I treat that AMI like, for example, Docker image. It's one pack, and then I apply that by using the AWS API. I'm using the rollout API, and basically what it's made the replace of root volume. So I'm just replacing the root volume on each machine. Of course, after using EBS drive. It's really important. And I do that node after node, blah, blah, blah. After that, I'm mirroring some percentage of traffic into staging to figure out if Cassandra behaves correctly and what's going on. Yeah, I'm using Datadog for monitoring, and after upgrading from 3.11 to 4.0, my latency goes up. It goes up basically for the right local performance, a little for read local performance. 99% Okay. So I think that maybe it's the issue on the node side. One of the nodes maybe made some flapping or some weird stuff. But I have another matrix that's showing me that the latency on each node goes up the same, in the same way. So I have some thoughts, so I go to enable node to enable some tracing, not generally on the cluster, not generally on the node, but only on, for example, SQLSH session to figure out when the time was consumed, why this latency goes up. And I figure out that the time was increasing the latency on the sending between the nodes. When I sending some response, when I reading that, before I reading that response, and so on, like you see on that slide. It's not animating, but the guy said, "What the fuck?" Okay, and now I can go to easy Cassandra Lab demo to make some live coding. Yes, thanks you for that. But I know that connection internet is not working correctly, so I prefer that live demo not on easy Cassandra Lab.
It's ruined the whole week.
You've chosen wisely.
Yeah.
Like nobody's gonna do like that.
Yeah, so that will be the live demo, but it will be not on easy Cassandra Lab, but on Docker, but on local Docker. So I not need my internet connection. So I can start from scratch because we have the time. I'm faster than I expected. So let's stop the current Docker container and let's start that from scratch. Okay, so I will spin up on my Docker, on my MacBook Pro, Apple Mac Pro, thanks Apple also for that laptop. It's ARM instance. One thing what I can request for Easy Cassandra Lab is the AMI for ARM instance. I love Graviton. If you want to save easily the money on AWS, on GCP not, but on AWS, go with the newest Graviton instance. It's 20 times cheaper and 20 times faster. But what is important to use Ubuntu 22 or newest, because previous Ubuntu don't interpret all the available cache on the node, so it's really not faster. Okay, from Pinops salaries for free without invoice. Okay, so I will stop the previous instance. I will spin up the new one. Yeah, it's created 4 hours ago. Even Docker is not so fast. So, there we go. Here is Cassandra, something to not type that. I prepare myself not type that commands.
Is anybody else gonna do a live demo? There's a reason. You got this, man.
Okay, so I'm in the good terminal session. That. Okay, the touchpad on one should be better. Okay, I don't want to write it from scratch, so I copy and paste. Okay, it's Cassandra Denver 7. Blah blah blah, it's initialized. It's the Docker image from Docker Hub, so nothing special. Normal Docker instance. I did not add there anything special. Let's wait a second. another instance in the meantime. So it was 7 for the seeds. It was here. Okay, 8. 8 and 9. Okay, let's wait a second. It's time for go. Do you know any do?
So what are you setting up here? Just a quick cluster so you can show the latency.
I will not show the latency, but I will show the behavior of Cassandra. The misbehave, which is the issue, which is the reason why my latency goes up. And as you see on the previous slides.
You're gonna make it break.
Yeah, I will fix that. I will fix that because it goes bad by default. But I'm not here to blame anyone. Okay, so one should go up, one more, and we can go further. Okay, so okay, yes. Where is the 9? Now I know why people are not doing like them. This is always time consuming. Okay, 9 is working, so Docker ps page, and there should grab that by Denver. There is a 9. There is a 9. Okay. Docker access. Okay. First thing, what I want to do is to change the default snitch algorithm, which snitch algorithm we are using. Is a question for audience. You don't care. So I changed to gossip property 5 snitch, gossiping property 5 snitch on every node, because normally I use that on all my production environment. I don't use the simple snitch. I use that. So Docker exec 5e. And then read. Okay. Okay, that comment is for easy Cassandra lab. User local Cassandra current conf Cassandra YAM. If you are looking where is Cassandra YAM, it's there. Okay, normally on Docker is in etc Cassandra YAM. So once again, Docker exec, and it was changed, and on to others node also. So for 7 and 7a, if I set up gossiping property 5 snitch, I need to set up also where in which data center is my node inside the file, which is Cassandra RDC properties, of course. So now it looks like that. I take notes. Where is the third one? It should be somewhere, or I made some mistake. Never mind. 2 is enough. So let's also change that file. I'm close. Don't worry. Docker exec 5e seed Docker ps 4 and Docker ps 7a. Okay, Docker restart 5e to apply that change. Okay, for 7, 7a. worry, I'm ready close to show you something exciting. Parallel. Cassandra. Log. Okay, where is the one? Smooth 8. Is that one? Okay, and I will start one more time. That's one was the 8. Okay, so what I want to achieve. Normally, the framing should be CRC, so it means that my connection is on the local data center. Node. Docker. Okay. So I go one more time. Docker exit IT. Bash. Okay, run the Marisa. And connect 7.
Think you are out of memory, maybe?
It could be like that. So move some. If I do too much, if I prepare for that previously. Okay. I also need that one. So, to be honest, better not doing it. Okay, so I have now the clean situation. I could start from scratch, but I don't want to because it take another week. So let's back to presentation. I have the same on the slides what I want to present. So basically, when we are starting the Cassandra cluster, okay, I need to increase the font size. Okay, there is inside the code at Cassandra 4 the information if I should frame it, if I should compress. The situation if I should compress depends on the situation if I set up the internode compression to all or not, or if I'm inside the local data center, my connection inbound, outbound. So the crucial is that class, is that method inside the Java code of Cassandra is in the local data center. And for example, if it's true, the local center is the same, the connection should be treated by framing like CPC and without that no delay. If it's false, it should be added 4 with that delay. So basically, we are going here by string remote data center. And how Cassandra know if the second node is inside the local data center or not? It goes to the snitch algorithm. So we have to go back to the snitch algorithm. And the snitch algorithm, as I set up previously, is the gossiping property file snitch. And inside the gossip property file snitch is the method to determine if the node is inside the local data center or not. Get the local data center name, basically. And on the start, it's looking if the same node is the local node. If not, it goes to the endpoint state. If the endpoint state is null, it goes further. But for endpoint state, it needs the gossiper. But when I connect the seed node, the gossiper is not ready, basically, on the startup. When I connect from my node some seeds, gossiper is not ready, so I have to go deeper. So if it's not ready, when I go to the file snitch. So basically on the startup of the nodes, when my connection is set up, I'm not looking inside the gossip property file snitch because the gossiper is not ready, but I'm looking inside the Cassandra topology file. And inside Cassandra topology file, if I'm not set up, the default name of data center is this one. So that method will be returned that my node is not inside data center 1, but it's inside the default name DC1. If it's in default data center name, it should compress and it should forget about no delay flag. So the connection between the nodes, even if it's inside the local data center, it's not using this feature of no delay, and it starts to compress. And when I have more than 3 nodes inside the data center, the first connection to seeds will start the inbound and outbound connection with no delay, set up false, so with delay, of course, and with that compression. And it's the reason why it made that latency spikes. I want to present that, but maybe you want to go for the coffee. So after the presentation, if someone is interested inside, I will go back to the Docker and I will present that, how it's working internally. To figure out that, what that method return, it's very easy because we can little hack Cassandra, of course. So normally what I'm doing, I'm taking the class gossiping property by snitch, as it looks like. I go to my, for example, own project. I copy that class. Someone can tell me some number. Okay, 26, I will. Okay, so 25, for example. Of course, it should be the factor 5.9. It's now 2025. Blah, blah, blah. Inside that, we can cover the method of getting local data center. So it's also very easy. That's, we need to add here, for example, the sum. boolean in the data center. Example like that. Data center and points. And let's use guide to build that.
Constructor, I guess.
Sorry?
We haven't feeding constructor.
Okay. Like that, because I'm not refactor. Okay. Let's compare it one time. If I could remember, okay, if Cassandra will go to Gradle, or the class will be spotless, intensive time. And when I have that jar which contain just one class, I can easily, okay, I need something. Yes, I can easily that library copy into my Docker instance. One time, Docker start that one. Oh, never mind. I will go that after the session. I can go to that class basically. The tab is always your friend. Build, libs, and there is a jar, very small one. It's Java and it takes only 28 kilobytes. I can copy that and change inside my YAML the gossiping property file snitch from the original one to gossiping property file snitch 25. And I will be using my new class. After that, I will see that during the connection to 6 nodes, I'm not using the CRC but LZ4. Basically, it's for proving, but let's go back to presentation because like them was not working. Sorry for that. I set up some cluster and I do exactly the same. I go by tracing. I figure out that even if I have connection inside the local data center, some inbound communication, outbound communication is set up like LZ4. If you go to your Cassandra system log, you will see that during the startup, there is starting the connection between the nodes, and it will be printed if it's CRC or LZ4. LZ4 should be between the nodes which are in different data center, but because there is some bug, I could say, it will start even if the nodes are inside the same data center. So we can deal with that. Okay, and the result, the latency goes down. Basically, based from snitch. And there are two workarounds on that. The first one is to set up this inter-DC DPC node delay to false. There is the first workaround. Node to compression. Of course, if you have more than one data center, it's good to have that compression between data centers. But 95% of cluster which I have are just single data center. So they are deployed only in one AWS region or only in GCP region. So I can, for example, disable that, and I'm happy. The second workaround is to set up inside Cassandra topology properties the seed nodes, in which data center they are. Doing that, when we are connecting without the gossip ready, we will be know that some nodes are in different data centers, and some nodes are in the same data centers, what we want to achieve, basically. So after changing that to parameters, there is the result in production. Here's even better results. Yeah. And I have also some lesson learned. So if I have staging cluster, because there is GitHub normally, so deployment, test, acceptance, production. If I have staging cluster for sample post testing, it shouldn't contain just 3 nodes, because if I have production which have 30 nodes, and I work in some behavior of Cassandra on just 3 nodes, it could behave differently. The next point, every parameters could be important and can make a difference. The corner case situation is also made because inside the seed list, I provide DNS address, not IP. When I provide DNS address, there is inside the Java the code which comparing the streams. So the string is not comparing because I provide DNS instead of IP. So if I want to check that, it's good to use exactly the same configuration. Comments may be misleading because these parameters of no delay, it's written that if the connection is between data centers, the parameters will be by default, for example, set up. But if I connect inside data center and it still enable this delay, so it means that it's little misleading me. It's good always to go to pick up and figure out what's going on. And there are also some corner case scenarios, and that's why life is interesting. If everything is straight and there is no pitfalls or something like that, the life will be very boring. Oh, okay. And thanks for your attention. And
Did you report this bug?
not yet. I want to report that.
You just fixed it.
I just write that workaround, which work in my scenarios, as you see on the chart, work correctly after going to Cassandra 4 and use the Netty connection inside, the latency goes down. But to be honest, that parameters of no delay also exist in 3.11, but it's not behaving that way.
Yeah, I think the issue was that gossip was not initialized when the initial connections were created, right?
Exactly.
Which makes the property files which...
Yes, exactly. So if I not set up the correct data center inside my property files, I use in class default, which is DC1 by default. So Cassandra figure out that the second node, the seed node, is from DC1, not from data center ABC, for example.
What tool are you using to measure these latencies and this?
Sorry?
What tool are you using to measure these latencies and plot it?
For that latency graph, I'm using Datadog. There is observability tool. In past, in Visa, we are using, like everyone, ELK, Elasticsearch plus Grafana, Logstash, and Grafana. Someone decided to pay for Datadog, and we are moving to Datadog with every log, with everything. After 3 months and 3 invoices, we are starting OpenSearch. And now the metrics are inside Datadog and logged in OpenSearch. And it's normal life cycle of project. Someone goes inside and go there. It's so so cheap for you. It wasn't cheap for us. I'm using Datadog, and inside Datadog is Cassandra extension, which connects to JMX. I know Accent Ops doing that better, but it connects to JMX and also calling node tool directly. But it has two extensions inside, two agents. And also what is very interesting, the next behavior, that's when the communication was started for 4.0, on the different Datadog charts, I see that the traffic between the nodes goes down. I mean, in the kilobytes, the size of traffic goes down because it's starting to compress that, even inside the local data center. But it shouldn't. Of course, it not occurs on the cluster which contains just 3 nodes. It occurs when the nodes, when the number of nodes is 6. When the cluster contains 102 nodes divided by 3, it also not occurs. It was the connection to 6 nodes. It's like 3% of overall connection. So I also doesn't see that. I didn't see that latency spikes. But when the cluster is the medium one, it will behave like that.
Is there any other questions?
Thank you.
Thank you.